Hi class, this is course 3, lesson 20, triangles. Two important ways that you can classify triangles. One, you can classify triangles by the number of congruent sides. We talked about congruent sides in lesson 19. Congruent, remember, means they are equal to. It also means, if they give you the symbol, that means congruent. I guess I can make that a little better for you. The little curvy S over the equal sign, that means congruent. So if we have a triangle, we can identify the number of congruent sides and then they have names. So scalene triangle has no sides that are equal in length. So notice that we have a 1, a 2, and a 3. Now that doesn't tell you how long the sides are, but it tells you that this side is different length than this one and different from this one. Those are tick marks. None of them match up, so this has no sides equal. Okay. An isosceles, now please make sure you spell isosceles correct when you have it on your assignment. Isosceles triangle, notice the tick marks again. We have a side and a side, they match up, they have the same number of tick marks. So we have 2 sides equal. And an equilateral triangle has 3 sides that are equal. Okay. Equilateral triangle. An equilateral triangle also happens to be a regular triangle. Okay, and so hopefully you remember that regular means, oh hey, all those angles are the same measure as well. Now we can also classify triangles by the angle measures. Okay, so we classified by sides. Now we're going to classify by angle measures. A right triangle has the little box in one of the corners, or it might tell you that you have a perpendicular, but the right triangle has one 90-degree angle. Okay, exactly one 90-degree angle. An acute triangle will have 3 angles that are acute, and an obtuse triangle will have 1 angle that is obtuse. Okay, so do you know why we can only have 1 obtuse angle and 1 right angle in a triangle? Let you think about that for a minute, and I'll explain it right here. The sum of the measures of the angles of any triangle is 180 degrees. Okay, so if we have, and I'm going to go back to the other slide here, if we have 1 right angle, if this is 90, then the other 2 angles have to add up to 90 as well. Well, I can't have 1 more 90-degree angle, then I'd only have 2 angles in my triangle. 90 plus 90 is 180. So that's why we can only have 1 right angle. An obtuse angle, similar logic. Obtuse angle is greater than 90 degrees, so I don't have more than 90 degrees to give to 2 other angles, right? If I used 90 or 100, if this were 100, I can't have another angle that's 100 because then I would have more than 180 degrees. Okay, so 1 90-degree angle, 3 acute angles, 1 obtuse angle for classification. But the sum of the measures of the angles of any triangle is 180 degrees. So in this triangle, I have 2 35-degree angles, and I have angle C that I want to find the measure of. So I know that the sum of angle A plus angle B plus angle C, and technically these should have M's, right? Measure of those angles has to equal 180 degrees. Well, I know that this is 35 degrees, right? Measure of angle A plus the measure of angle B is 35 degrees plus the measure of angle C has to equal 180 degrees. I can add these up. That's 70 degrees plus the measure of angle C has to equal 180 degrees. And since I'm looking for an add end, I would subtract 180 degrees minus 70 degrees is going to leave me with 110 degrees for the measure of angle C. Okay, so I know that this is 110 degrees. Now, let's classify this triangle by sides and by angles. And this is a typical type of question that you will be asked. And notice there will be two answers. So make sure you answer both of the questions. So classifying the triangle by sides. So I need to look at my side lengths. And it doesn't tell me what my side lengths are. Okay? That is because I did that on purpose, but let's do that one in a minute, okay? Because we're going to have to go back to one of the drawings and add something. Let's classify it by angles. So look at the angles. I have two acute angles and one obtuse angle. So by angles we have, this is an obtuse triangle. Okay, one obtuse angle makes it an obtuse triangle. Okay, so I'm going to flip back for a minute. We need to take a look at this isosceles triangle, because in this isosceles triangle we have two sides that are equal, and we also have two angles that are equal. Okay, the base angles of an isosceles triangle are going to be congruent. We talked about the equilateral triangle a little bit, the regular, that it has three sides that are equal, so it's a regular triangle. And an equilateral triangle is going to have three angles that are congruent. Okay, but this is the one, and see, I just gave it away. Because our base angles are equal, then our sides are equal. Two base angles are equal, and again, these could be over on the side. I could have a triangle oriented like this, and these could be equal. Still the same type of situation. But since my base angles are equal, then I know my sides have to be equal. And because I'd have two sides that are equal, it would be an isosceles triangle. Okay, make sure that you have that written down, that those base angles right here are going to be the same. Okay, that's an important thing to note about an isosceles triangle. One last thing, area of a triangle, the formula that you need to know is area equals 1/2 times base times height, or just area equals 1/2 base times height. So we're going to take a fraction of a half, multiply it times b and h, base times height. The base and the height are perpendicular. Okay, so wherever you have your right angle, that's where you're going to get your base and your height. Okay, you may have worked with this formula before, where it was area equals base times height divided by 2. Okay, that's fine too, but sometimes it's easier when you have the fraction, that you can see some things that you can do than when you're just dividing by 2. So let's take a look at this triangle. Where do we have the perpendicular? Where's the right angle? It's right here. So we have a height and a base. Now, this could be our base and this could be our height. You just need to take the two where you have the right angle and multiply them together with 1/2. So we're going to take area equals 1/2 times 6 times 7. Okay, now since this is a fraction, I can cancel or divide out from the numerator to one of these factors. So I could do this, divide by 2, divide by 2, and that equals 1 times 3 times 7, 21, and there's nothing in the denominator anymore. And then remember, this is area, right? And it was centimeters, so we're going to have centimeters squared. You could have taken area equals, let's do the one that I think you're more familiar with, 6 times 7 divided by 2, and then we would have had to have multiplied 6 times 7, 42, divide by 2, and that would get us 21 centimeters squared. It's just that if you can see that you can do some of this division first before you multiply, sometimes it keeps the numbers a little more manageable for you. Okay, so just remember that we're looking for the perpendicular, wherever we have that perpendicular, that right angle, that's what we're looking for to determine where we have a height and a base. Okay, please let me know if you have questions. Otherwise, that's it for today, and I will see you in class.